I can.
Oh, sorry, I was mute.
Okay, okay.
Sorry. I'd like to invite Luca for the next presentation. The paper is entitled Neverlang and FeatureIDE, Just Married, Integrated Language Product Line Development Environment. So Luca, be my guest to share your screen and your presentation.
Okay, hi. Thanks, Edson, for the great introduction. Sure. I guess I don't have to introduce myself now, and I can start right off. But actually, I would like to start from the basics because, you know, if you are interested in software product lines and language product lines in particular, I think there is one thing that you should like even more, and that is tiramisu. Okay, that's an easy bet, but why? What do they have in common? What do tiramisu and language product lines have in common? Well, you know, everyone think they know how to make tiramisu, but in reality, there is no such thing as tiramisu. What you have instead is a bunch of similar, related, but still different products, which are different dishes indeed, but are similar enough to be classified as a family of dishes, the family of tiramisus. Well, the same applies to languages too. You have, for both general purpose languages and domain-specific languages, you have one language, and then you can tweak it to create variants of the same language, and the collection of all the variants of the same language create the language family. There are some very neat examples in literature, so I suggest you go check them out. Okay, but what if we want to create our own family of tiramisus? Well, you have to start from scratch, from the ingredients. So you have a bunch of ingredients that you can choose and pick to create a new recipe. So you can combine all the ingredients into a new recipe, and choosing different ingredients will lead to a different recipe. Once again, the same applies to languages, and you can have language features, language components, which you can combine into compilers and interpreters. To do so, you need what we call a language development tool or a language workbench. Okay, now we know how to create our own tiramisu family, but how do we make it good? What makes a great tiramisu? Well, we argue that you need a restaurant, an environment to create this family of tiramisus. And this environment should have two main characteristics. First, it should be in Italy. And second, it should provide for the needs of a few different roles. And these roles are someone who can provide you with the best ingredients, un pasticcere, and next, someone who can combine those ingredients into a language product, right? A chef. Okay, so since the two decided to open a restaurant together, it's even better if the two are married. And we're done, right? Well, I'm afraid we are not, because, you know, you can create the best tiramisu out there, but it is not much worth if nobody is eating it. So what you need is also customers, so someone who can eat your tiramisu. Okay, but how should the restaurant support the activity of these three roles? Through an engineering process. First, we have the developer, the language developer, so our pasticcere, that creates the ingredients, so the language components, and collects them into an informative representation that we call a feature model. Next, we have the language deployer that inspects the feature model and chooses and picks the ingredients from the feature model to create a new recipe, so a new language variant. And the collection of all the language variants we created, the deployer created, is what would be the menu of a restaurant. Finally, the user just has to come into the restaurant and choose from the menu the favorite variant and eat it. If for any reason an issue comes up, the diagram is traversed the other way around, starting from bottom to top. So the language user has to complain to the language deployer, and the language deployer has to complain to the language developer. This is kind of convoluted, but please let me show you an example. Let's assume you have a very healthy language product line with all kinds of language variants and a bunch of behaviors implemented in language components. However, one day a new user comes in and asks for a new feature that nobody asked before. Now the deployer has to inspect the feature model and create a new language variant that implements the required behavior. But unfortunately, there is no such feature. So the deployer asks to the language developer to create said behavior, said language component, and thanks to the fancy environment, the kitchen where the developer works, creating this new feature is easy enough. The feature model is updated, and the deployer can undergo the configuration process and create the new language variant. Finally, the user just has to pick the new variant from the menu and eat it. Okay, where's the problem then? The problem is that, to the best of our knowledge, there is no such an environment that supports all the three roles. What you have is maybe an environment that supports the activity of the developer, the activity of the deployer, rarely both. And even if the environment can be used to create an interpreter or a compiler, so a tiramisu, that then the language user has to pick and bring home to eat at home. To overcome this obstacle, we married the state-of-the-art in software product line and language product line engineering, so namely FeatureIDE and Neverlang IDE respectively, to create an integrated language product line development environment. Here you can see a screenshot of our environment divided in 3 layers, one for each of the 3 roles. On the first layer, you can see the views and the editors that are made available to the language developer to create new language features, and the feature model view that is updated whenever a new language feature is created in a bottom-up fashion. On the second layer, you can see part of the configuration process that the language deployer undergoes to create new language variants. And finally, on the bottom layer, you have the editors and the consoles that are generated automatically by the language specification and that the user can use to take advantage of the language variants from the language family. Okay, so what about we see it in action? Please remember the example I did earlier, because it will come in handy. Okay, in this example, the language user wants to create a simple script to compute the factorial of 5 using a JavaScript variant. The language user creates the script and execute it by using an Eclipse running configuration for Neverlang. But unfortunately, the execution yields an unexpected result. To spot the bug, the language user would like to log all the assignments to variables in his source code. The language deployer inspects the feature model to find if any feature like that is implemented, but unfortunately there isn't any. So it's the turn to the language developer to create said feature. And thanks to the Neverlang editor, creating this feature is easy enough. And also the environment updates the feature model automatically. And now the feature model includes the new language feature. Finally, the language deployer can undergo the configuration process and update the language variant the user was using to include the new logging feature. the language deployer also adds an additional phase to the interpreter so that the logging is actually performed. As you can see, the Neverlang source code is generated automatically by the environment. Now, the user just has to run the script as it was, and the execution will log all the assignments to variables. Thanks to this new feature, the user is able to spot the bug and fix it. And now running the script again will yield the correct result. Okay, so to showcase the applicability of the engineering process and of the environment for said process, we made a case study for gradually teaching programming through 14 language variants from the JavaScript family of increasing complexity, with the addition of one more variant for the complete JavaScript implementation. As you can see here, there are a few stats from the language family, and also to simulate the distributed and incremental development process, we used Git. Here you can see a few commits that were necessary to implement variant number 8. The Git repository is available online, so please go check it out if you're interested. So, in conclusion, our contributions are a language product line engineering process that supports the incremental and distributed development of language families, and that can handle conflicts through variability. That means that we don't have to prioritize among conflicting user requests, because we can simply deploy different products to different users without having to prioritize. Next, we created an integrated language product line development environment by marrying the state-of-the-art in software product line and language product line engineering to address this issue and to support this engineering process. The environment also supports consistency, preservation, configuration, deployment, and usage of language families and language variants belonging to said families. Okay, I hope you enjoyed my presentation, and I hope I will be able to answer any of your questions.
Great. Thank you, Luca. It was a great presentation, very interesting work. We have a question in the Q&A, an anonymous attendee. How do you create a new language product line from scratch? Which roles need to do what?
Okay, so okay, the language deployer, I mean, the language user usually is the first that is asking for a new behavior. So usually you start from a user request. Then the combined effort from the language developer and the language deployer can effectively bring the language family to life. To create it from scratch, you usually have, you start by creating one single configuration, and then the developer creates all the modules, so all the features that implement the interpreter or the compiler for that specific language configuration, and the initial feature model is a byproduct of this first implementation, because with Neverlang and IDE, we apply a bottom-up approach. So the feature model is generated automatically from the language artifacts. Next, once you have the initial feature model, you can easily extend it and follow the incremental development by adding additional features that are triggered, that are requested from users. I hope that answers.
I think so. I have a question. In an environment of multi-systems, like system of systems, and we have where we have several feature models, one for each system. Does Neverlang have any way to put some constraints from one feature model to another one? Because you showed the generated feature model, but it's only one feature model, right?
Yes.
Is there any way to provide these constraints from, for example, in a system of systems environment, one system might constrain or change the behavior of another system, something like this?
Yeah, we currently do not support this kind of behavior with Neverlang. So you would instead have to use kind of a mixed approach. So create the separate feature model independently, and then define the constraint between the different feature models manually. However, we are working on this currently, not rather for this topic in particular, but we are working on multi-trees for multidimensional feature models. So we are looking forward to support this kind of behavior too.
We have no more questions. We have time for one more. Do you think Neverlang can evolve to, for example, provide any support to model variabilities in reference architectures? We can model in the meta level of an architecture, right?
Yes.
Do you think it's possible to provide this embedded in the FeatureIDE environment?
Okay, we never used it for this kind of application. However, Neverlang would be best suited for, you can, I guess you could implement a modeling language. Since you use, the semantics are implemented in Java, so you are kind of free to do basically anything. So, I mean, I don't see why not. I didn't do this on myself, but I guess it could be done.
Okay, so is Neverlang available in a Git repository for volunteers to contribute?
Okay, Neverlang is currently not open source, but it can be used and can be accessed by the official site. I would recommend you speak with Walter Cazzola, with the head of the project. You can see how to contact him. And usually we are very welcome to include anyone to support if they are interested. So there is no public repo, but you can ask and maybe we can share.
Sure. We have another question from Jane. Language engineers usually do not want to start from scratch or leave their current tools. Do you see in the future options to migrate existing languages?
I guess, I mean, yes, at least for the syntactic level, I see that could be done easily enough. Translating semantics would be a different kind of problem, I guess. But yeah, I see that's a foreseeable future. The good thing in general for a modular approach to the implementation of languages is that you have greatly increased reusability. So, I mean, the effort of migrating is luckily, I think you have to do once, and then you could use the same implemented features again in any kind of language family. So,
okay. Thank you, Thomas, for your comment on the second question. So, Luca, thanks for your presentation. Very good presentation and very good works here in this session. Stephanie and Luca, congratulations on them.
thank you.
And Roberto, it's up to you.
Yes.